Dimensional analysis. Dimensional analysis helps us to work out if a formula can be used to calculate length, area, or volume. There are some formula that you may already know for these measurements, such as for a rectangle, the perimeter, the length around the outside, is given by 2L plus 2W, and the circumference of a circle is also a length given by 2 pi r. For area, formula you may know over a triangle, where area equals half times base times height, or a square, where you can find the area by doing width squared. Volume of a cuboid is given by length times width times height, and volume of a sphere by 4/3 pi r cubed. Let's look at how we can determine the dimensions of these formulae. Taking length first of all, we had that the perimeter of a rectangle is 2L plus 2W. To help us complete dimensional analysis on this, we can follow a few rules. Constants, the numbers used in multiplication and division in the formula, don't have dimensions, so they can be ignored in dimensional analysis as they don't have an impact. 2 times a length is still just a length. Next, we can replace any length used with a capital L. And then, when we go on to more complicated formula, we also need to know that only quantities of the same dimension can be added together. So you cannot add together an area and a volume, for example. But if we added 2 areas, we still just get an area out of it. When we complete dimension analysis on a formula, lengths will end up with dimension L, area L squared, and volume L cubed. A bit like how length is measured in centimetres, area in centimetres squared, and volume in centimetres cubed. So let's apply these to our perimeter formula. If we ignore those constants, we just have that the dimensions of perimeter are the dimensions of L plus W. These both have the dimension of length, so we can replace them with a capital L to get L plus L. We know a length plus length is just a length. So the dimension of perimeter is length, as expected. If we do the same with circumference, our dimension of circumference is dimension of r after we remove those constants, remembering pi is just a number. And radius is a length, so let's replace it with a capital L. So circumference is a length. Again, this is exactly what we expected, as we know both perimeter and circumference measure length, so we'll have dimension L. Let's follow the same steps for our area formula, and we should get that they have dimension L squared. For a triangle, let's ignore that constant, in this case of a half. Replace both lengths with a capital L, and we get L times L, which gives L squared, as expected for an area. For a square, we have the formula W squared. There are no constants to remove in this case, as the squared is an operator, so this just becomes the dimensions of W squared, which is L squared, just as we expected. Finally, let's check those volume formula. For a cuboid, we have this formula. Again, there are no constants that could be ignored here, so we just need to know the dimensions of L times W times H, these all of which are length, so our dimensions become L times L times L, which can be written L cubed, as we would expect for a volume. Our final one to check was volume of a sphere. Pause the video here and have a go at confirming that the dimensions come out as L cubed. Well done if you're working lit like this. Now let's take a look at doing dimensional analysis on a formula that we don't know. We are told that F, G and H are all lengths, and we still have our helpful steps for dimensional analysis. We want to find the dimensions of 3FG squared. So following our steps, we can ignore that constant as it's dimensionless. So we need the dimensions of FG squared. We know each of F and G are length, so replace them with L. And so we have L times L squared, which becomes L cubed. So this formula gives us a volume. The next example involves a fraction, but let's just follow the same steps as before. There are no constants to remove, so we need the dimensions of FG squared H over the dimensions of H squared. Each letter is a length, so let's write each one as L. Tidy up using powers, we end up with L to the power of 4 over L squared. And using our knowledge of indices, this will become L squared. So this formula is an area. This question has multiple terms in it. So, like in this first one, let's take each one in turn and find the dimensions, ignoring any constants. Replacing every length with L. Let's tidy these up a bit, our indices. And we end up with L squared plus L squared subtract L cubed. But we've got a problem here. We know that only quantities of the same dimension can be added together, and so this form does not represent area or volume. Here's one for you to try. Does this represent length, area, volume, or none of them? Pause the video and have a go. Your working may have looked like this. Find the dimensions ignoring numbers, replacing with L, tidying up, and combining 3 volumes will give us a volume. Well done if you got that one correct.